Students, in this video, I'm going to discuss bisection method. Okay, so this method is based on the repeated application of the intermediate value theorem. What is the intermediate value theorem? Intermediate value theorem says that if suppose this is your function, this is then and this is the domain from here to here. This is the domain of the function. Say here point is a, here is b. Then if the value of the function at this point is suppose negative, and the value of the function at the right hand point is positive, that means they are having opposite sign. Function is having opposite sign. Then at these points, then obviously the product of these two values f of a and f of b will be negative. Then function intersects x-axis at odd number of times. At odd number of times, maybe 1, maybe 3, maybe 5, etc. Okay, so here we are repeatedly apply this theorem, intermediate value theorem, in this bisection method. Fine. What is the strategy? Strategy says that, as the name suggests, bisection means bisect. So here we will for example, a0 b0 is the initial interval. Okay, and you can see that the f of a, this distance is basically f of a, this distance is f of b. Here this end is negative because this is the origin point, this is the x-axis. Okay, so this is negative, this is positive, so obviously by intermediate value theorem there will be a root, at least a root. Okay, so now what we will do, we will bisect this interval a0 b0 in two equal part a0. So suppose this interval is bisected at the point m1. m1 is exactly the midpoint of a0 and b0. Between these two, m1 is exactly at the midpoint. Okay, so initial interval from here to here is denoted by I0, this I0, and now m1 is the midpoint. So m1 is midpoint means m1, you can easily find out m1 is nothing but either you can say a0 plus b0 by 2 or a0 plus this distance, both will be same. So a0 plus what is the distance? This distance is a0 plus b0 by b0 minus a0 by 2. This distance b0 minus a0 by 2. This distance. So if you add this distance, I'm saying distance, this distance in a0 point, then we will reach to the m1. Okay, so a0 plus b0 minus a0 by 2 is a0 plus b0 by 2. So this is the basically the coordinate of this point m1. Now here we have two intervals, a0 m1 and m1 b0. So aim is to select suitable interval so that we can again apply intermediate value theorem in the subinterval either a0 m1 or m1 b0. Okay, so what is the mandatory condition for intermediate value theorem? Condition should be that the functional value at the endpoint should be opposite. So if you select, for example, a0 m1, then what we will find? You will see that here the negative value, and at this point function value at f of m1 is again negative because this is in the lower half. So that's why this is negative, this is negative. So intermediate value theorem is not applicable. However, if you are taking the interval m1 to b0, then you will see that here the value is negative. Here at this point the value is positive, so opposite to each other, and that's why you can again apply intermediate value theorem. So that's why next interval will be I1, and this a0 m1 is discarded. There is no need to consider this interval because there is no root in this interval. Fine, so the next interval will be I1. So in general we can say that what is I1, how to select I1. I1 is either A0 to M1, this interval, if the product of the function values f of A1 and f of M1 is negative. Or either you can select M1 to B0, M1 B0 if f of M1 into f of B0 is negative. As far as this figure is concerned, here we are taking the second part, M1 B0. But in general, this may happen that for another example, suppose your curve may intersect here, this point from here to here. So that's why you can take the first part. So in general, I1 is nothing but either A0 M1 if this condition holds and M1 B0 if this condition holds. Okay. Now once you are getting I1, so in this figure this is the I1. This is the I1. Now again bisect this interval into two parts. So find out M2. M2 will be what? M1 plus B0 by 2. M1 plus B0 by 2, or we can say that this M2 is equals to, for example here is according to this figure, M2 is M1 plus B0 minus M1 by 2, or M1 plus B0 by 2, this. So this is equal to, what is M1? M1 is this, we have already evaluated, A0 plus B0 by 2. So A0 plus B0 by 2 plus B0 divided by 2. So what we will get? We will get A0 plus this A0 plus, because we want to write down the general formula. Okay, so here we are saying that this in the next interval, this point we have selected this interval, so this is say A1 and this is say B1. We have renamed this M1 as A1, B0 as B1. Okay, so A1 plus B1 by 2. So here this can be written as, there is no need to write down this because we want to find out the general formula. So M2 will be what? A1 plus B1 by 2. A1 plus B1 by 2 is the midpoint. Okay, as far as this is, M1 is A0 plus B0 by 2. M2 is A1 plus B1 by 2. Similarly, M3 will be A2 plus B2 by 2 and so on. Okay, so now we are trying to find out the general interval. So based on this, we have selected this. In the next interval, if you will see this figure, then again bisect the interval. So we are getting M1 M2 or M2 B0, two intervals, and according to, we have to select one of them. So as far as this figure is concerned, we will select this interval because here the value is negative, here is positive. However, in this interval, this value is positive, this value is positive, so their product is positive, so there is no need to consider this interval. So the next interval I2 is basically M1 to M2, and this is renamed as A2 and B2. Okay, so in general, if you are following this way, I0, I1, I2 and so on, so the next interval will be Ik plus 1, which is either, if you will see I1 is A1 B1, I2 is A2 B2 and so on. So Ik plus 1 will be Ak plus 1, Bk plus 1. Okay, and this is what, according to this, if you will see here, I1 is A0 or M1 or B0. Okay, if here is 1, here is 0 and here is 1, here is 1, so here is 1 and 0. Similarly, if here is k plus 1, so this should be k, Ak. Okay, and this should be Mk plus 1 and this should be Mk plus 1 and Bk. Okay, so based on the same pattern, we are having Ak plus 1, Bk plus 1 as Ak, Mk plus 1 if the product of the functional values f Ak and f of Mk plus 1 is negative. Similarly, you can select this second interval Mk plus 1 to Bk if f of Mk plus 1 into f of Bk is less than 0. Okay, so this is the procedure. Now how to stop? because you are regularly shrinking or just bisecting the interval I0, I1, I2, I3, I4 and so on. So where we have to stop? This is the problem. So now if permissible error is epsilon, epsilon error means what? Error is this. Suppose this is the exactly, so this is the true, this is the true root xi, and we are trying to find out the root. Okay, so since we are trying to find out the root, so what will happen? We are continuously shrinking the interval. Okay, so we are continuously shrinking the interval, so or bisecting the interval. So what we will do, we will just take for example this. Initially we are having this interval, then bisecting the interval. So we have selected this interval, again bisect the interval. So initially we are taking say this m1, then m2, then and so on. Finally, suppose after number of iterations you reached at this point, say xi star. We are denoted this xi star. So if you will see that here this distance is negative, this distance, and here we have this distance. So if I am zooming this, so what we will get? So after zooming we are having say this type of pattern here. This is the x-axis here, this is your xi. मैं इसको थोड़ा बड़ा कर देता हूँ समझने के लिए. Here is xi star. So this is your true root or actual root, and this is the approximated root. ओके, सो ये हमारा एग्जैक्टली रूट है, दिस इज द अप्रोक्सीमेटेड रूट. हम एग्जैक्टली नहीं, न्यूमेरिकल एनालिसिस बेसिकली वी आर नॉट able to find out the exact root. We are not able to find, we are trying to reach towards the exact root. Okay, so suppose this is the nearest, हमने जो कैलकुलेशन किया हम यहाँ तक पहुँच पाए. So still you can see this is the error, this is epsilon, this is the error, this is the error. Similarly, so what we can say here, the magnitude of xi minus xi star, this is less than epsilon, because xi may be here or may be here, xi star, that's why we am taking the magnitude. Okay, so this is the one way. Second thing is that because you can see function is of this form, so here suppose this is the, so function is moving like this. Okay, so if you can easily see that here the functional value is 0, f of xi exactly 0. However, f of xi star, this distance may be some value, say negative, in this case this negative. Okay, so now if you will see, if you are finding the distance, the difference between this and this value, so what you will get? F of xi star minus f of xi, just like this. और इसको मैं xi बना देता हूँ, सेम पैटर्न, इसको xi star. Rather than finding this, we are finding the functional value at these points. So again this should be less than epsilon. So we have to stop the method. Either we can use this approach or either we can use this approach. यानी कि जीरो के जितने नियर हम जा सकते हैं फंक्शन को लेके, तो स्टॉप करने के लिए चाहे तो हम इसका क्राइटेरिया का इस्तेमाल करें और आइदर यू कैन यूज द फंक्शनल वैल्यूज, बोथ विल बी एप्लीकेबल. एंड दिस you will see that in my previous video we have already shown this thing, we have already shown this. To stop the method we have already shown this here. If you will remember in my previous video, either we can use this, because what is this, this is 0, so this is 0 minus f of xi star is less than epsilon, so this is nothing but f of xi star, this should be less than epsilon. Okay, so this is the way. Similarly the second, this, so in terms of recurrence formula we have written this, so both are same. Okay, here xi star is obtained after k plus 1 or k number of iterations, so that's why they are written in the recurrence form is this. So either you can stop the method, either you can use this approach or this approach. Okay, so this is the meaning. Okay, as far as our method is concerned here, so here you will see that we are continuously bisecting our intervals. So after n number of iterations, initially what is the interval? If you will see, initially we have the interval this a naught b naught. After one iteration, for example, say we have this interval which is nothing a1 b1. An interval will be of the length b naught minus a naught. Here the length of the interval is b naught minus a naught. This is the length of the interval. What is the length of this interval? The length of this interval divided by 2. So by 2. This is the length of this interval. Again, suppose you have selected this. This is your a2, b2. Second interval. What will be the length? The length of this interval divided by 2. But the length of this interval is this. So just divide this by 2. So we have a b naught minus a naught by 2 into 2. That means b naught minus a naught by, this is multiply. So 2 square. So after, say here, n number of iterations. This is first initial, this is after first iteration, this is after second iteration, after n number of iterations. Suppose we have the interval an bn. So what will be the length of this interval? The length of this interval will be b naught minus a naught by 2 raised to the power n. Because after second interval, we are getting 2 raised to the power 2. After third, we will get 2 raised to the power 3. This b naught minus a naught by 2 raised to the power 3. So after nth, we get b naught minus a naught by 2 raised to the power n. This is the length. Okay, so the length is shrinking continuously, and you will see in this is basically what is this? This is the length. This is the length of the interval. This is the length of the interval after n number of iterations. Continuously shrink हो रहा है, shrink. So after n number of iterations, this is the nth interval. Nth interval. Okay, the length will be the difference between these two endpoints. That means this should be less than epsilon. So that's why we can say that this is the length after nth interval. This should be less than epsilon. And this is the stopping criteria. If you are following the first approach, if you are following this approach, then obviously this is epsilon. This is nothing but xi minus xi star after nth interval. So this is the length. This should be less than epsilon. Okay. So now based on this, you can easily find out, from here you can find out n. Okay. So here is this procedure. So after nth iteration, we have this b naught minus a naught by 2 raised to the power n. This is the length of the nth interval. This length should be less than epsilon if this is the possible error. Okay. So from here, if you are taking both sides logarithm, then what you will have? We will have this. N is greater than equal to, because what we will have? Here we have b naught minus a naught by 2 raised to the power n is less than epsilon. Take both side logarithm. So log b naught minus a naught by 2 raised to the power n is less than equal to log of epsilon. Okay. Now here this can be written as log b naught minus a naught minus log 2 raised to the power n is less than equal to log epsilon. This if you are taking in the right hand side, and this log epsilon is taking in the left hand side, so we get log b naught minus a naught minus log of epsilon is less than, this can be written as n log 2, and from here you can find out n is greater than equal to log b naught minus a naught minus log of epsilon by log 2. So from here, if b naught a naught is known to you, epsilon is given to you, permissible error is given to you, then you can easily find out number of iterations. Okay, So this is the formula. From using this formula, you can easily find out the number of iterations used in this bisection method to solve a particular problem. So if you are taking a naught as 0, b naught is 1, that means interval is taken as 0 to 1. For a particular problem, suppose this is the interval 0 to 1 and epsilon is suppose 10 raised to the power minus 2. So a naught is given to you, b naught is given to you, epsilon is given to you, this value. Then n will be 7. Number of iterations required 7. If epsilon is changed for the same interval, this 10 raised to the power minus 3, then number of iteration is 10. Similarly, if epsilon is 10 raised to the power minus 4, then 14 iterations are required to get the approximate solution. Okay. So here we have taken two examples. One is this. This is a polynomial, or so this is basically the explicit. This is the explicit problem. A polynomial is given to you. So perform iterations of the bisection method to obtain the smallest positive root of the equation with epsilon is equal to 0.001 in the interval 0 to 1. So this is your a naught, this is your b naught, and this is your epsilon. Epsilon is this. If you will see here, epsilon is this, interval is this. So this is nothing but 10 raised to the power minus 3. So according to this, because this is again 0 and 1, this is also 0 and 1, epsilon is this, which is nothing but 10 raised to the power minus 3. So n is 10. That means you have to perform minimum 10 iterations. Minimum 10 iterations. This is actually the less than. This is less than. This is less than. So this should be greater than. Okay. So this is greater than. Okay. So here when you perform this and solve this, so what you will get after solving this, just put it the values here and here. So you will get n is greater than, this is greater than, n is greater than 10.97. That means 11 iterations are required. Okay. So after 10 iteration, here is 10, because after 10 iterations you have the point, and in the next iteration basically you have to just bisect. There is no need to perform any iteration in the 11th. That's why you can add one more thing. So here is this. So total 11 iterations are required. Okay. So let's see. So this is the k. K represents the iteration number. AK minus 1 represents the left hand point. BK1, f of A is basically the value at the left hand point. Here I am not using AK minus 1. You may also write down this. This is basically AK minus 1. Okay. The functional value at this point. So here I am not interested to find out the exact value. Rather we are interested in the sign. What will be the sign? Whether positive or negative. Similarly, this BK minus 1 is the right hand point and the functional value denoted by FB or B minus 1. Then we have evaluated the midpoint MK minus 1, midpoint of AK minus 1 and BK minus 1, the midpoint of these two. So this is denoted by MK minus 1. Again, find out the functional value, and this is the sign, whether positive or negative. And based on the sign, now we have to apply the intermediate value theorem. So here we have fixed the sign. Here I am not considering both these things. Here I am taking this part. If this will, either this will apply or this will not apply. If this will apply, so we can take the basically this condition. If this condition holds, then obviously we have to choose this interval. If this condition does not hold, so obviously the second interval will be used. That's why there is no need to find out both these conditions. Only one condition is sufficient. So that's why I am taking this condition. So here the condition is this: f of AK minus 1, that means the functional value at this point, into f of MK, f of midpoint. This will be m of k. Okay. If this condition is holds, we are evaluated the sign of this. If this is negative, then obviously then this will be the next interval. If this is not happening, then obviously the second interval will be taken. Okay, and then in the last we have evaluated the length of the interval, bk minus 1 minus mk minus 1. Okay, that means this interval. So either you can use this interval, or because both are same, either this or this, the length will be same, either you can use this or this. So now initially we have 0 and 1. So ak minus 1 is 0, bk minus 1 is 1. Now if you find the value of the function at the 0, then this will be a positive value. If you evaluate this value of the function at point 1, then this will be a negative value. So both are opposite to each other, so there will be a root. So now bisect this interval 0 to 1. So midpoint will be 0.5. Now find the functional value at this point, which is a negative value. So you now see the sign of this product. F of ak minus 1, that means positive value. F of mk, which is a negative value. So this is positive, this is negative. So obviously when you product these two, so obviously you are getting a negative. That's why less than 0. And since less than 0, so this condition holds. And since this condition holds, so the next interval will be am. Am means what? Am means 0 and 0.5. Because this is mth column. So 0 and 0.5 will be the next interval. So 0 to 0.5 means left hand will be 0, but the right hand is now in place of 1 we are having 0.5. क्योंकि next interval 0 to 0.5 हो गया है. तो ये अब आपका नया a1 हो गया है, ये आपका b1 हो गया है. Okay, here the sign is already evaluated plus, here the sign is already evaluated negative. Now take the midpoint of these two, which is 0.25. इन दोनों का midpoint 0.25. Again find out the functional value, so which is nothing but a negative value. So this is negative. So now you have, this is negative, ये तो फिक्स है. अब आपको इन दोनों में से कोई एक चूज करना है. And according to this, हमें वो चूज करना जो निगेटिव बनाए प्रोडक्ट. सो दिस इज निगेटिव, तो इसके साथ हमें पॉजिटिव लेना पड़ेगा. सो पॉजिटिव मीन्स दिस 0. सो द नेक्स्ट इंटरवल विल बी 0 and 0.25. So 0 and 0.25. Okay, so here is positive, at 0.25 negative value. So now take the midpoint of these two, which is in this 0.125. Evaluate the functional value, which is nothing but a positive value. So here the is positive value. Okay, so now you will see that this is positive, so you have to take the negative one so that the product will be negative. ठीक, तो इस पॉजिटिव के साथ हमें निगेटिव लेना पड़ेगा. निगेटिव मीन्स दिस. सो द नेक्स्ट इंटरवल विल बी 0.25 and 0.125. तो अब क्योंकि इंटरवल तो इंक्रीजिंग ऑर्डर में होता है, इंक्रीजिंग, सो अमंग दीज टू this is lesser than this value, so that's why this will be the left hand point, this will be the right hand point. So now this will move here, 0.125 with positive sign and 0.25 with negative sign. You can say this is an interval 0.125 and 0.25 increasing में है, बढ़ते हुआ है interval. So now take the midpoint, which is this, and find out the functional value. This is positive. So since this is positive, तो इसके साथ तो negative लेना पड़ेगा. That means this is the negative one. So this will be the next interval. So now again you can replace this quantity here in increasing fashion. So this is your A, this is your B. Again find out the midpoint. So this, and continue in this fashion. So after 10 iterations we are getting this. This is the midpoint. This is the interval. So you will see the interval is continuously shrinking. Initially the interval is 1. After one iteration 0.5 is the length of the next interval. After second iteration we have 0.25, and slowly after 10th iteration the interval is 0.00096766. And this is basically, you will see the length of this interval is less than epsilon. This is your epsilon. This is the length of the interval. So you have to stop it here after 10th iteration. So the next root will be what? After 10th iteration interval is 0.201172. 0.201172. This is your A column. This is the B column, 0.203125. This is B. Now take the midpoint. Take the midpoint. This is the solution. So midpoint is M. What is the midpoint? Midpoint is 0.201660. This will be the solution. Okay. So this is the solution. After this we have this solution. So this is the basically the solution. This is the solution. Okay, so this is the procedure. Here we have taken the problem, a polynomial, explicit problem. Now if we are taking the another problem, which is this second problem, transcendental problem. This is the transcendental problem. Function is cos x minus x e raised to the power x is 0, epsilon is 0.001, interval is 0 to 1. Again n is greater than equal to 10 point something आएगा. So that means minimum 11 iterations जो आपको करनी पड़ेंगी. So केवल 5 iterations को मैंने यहाँ दिखाया हुआ है. After 5 iterations पूरा complete iteration chart is this. So let's see. So either here only 5 iterations, here total 11 iterations. Okay, so I am illustrating this. Function is this, cos x minus x e raised to the power x is equal to 0. So you have to perform all the calculation through calculator. Okay, so calculator class में मैं बताऊंगा how to use the calculator, but initially because class is not happening, so in the class I will tell you short tricks how to use calculator. But before that, let's see. So this is k in number of iterations. This is your left hand point ak. This is your right hand point bk, and this is the functional value at ak. This is the functional value at bk. This is the midpoint column mk. This is the functional value at the midpoint mk, and then product between f of ak into f of mk. Okay, either this product is negative or positive. Okay, initially interval is 0 to 1, 0 to 1. Okay, so at 0 and 1, here the functional value will be positive, here the functional value is negative. Take the midpoint of these two, which is 0.5. If you evaluate the functional value at 0.5, then this will be a positive value. So since this is positive, this is fixed, ये हमेशा फिक्स रहेगा, इसी के हेल्प से आपको इंटरवल सेलेक्ट करना है. दिस इज पॉजिटिव, so you have to take the negative one. So this is negative 1. So obviously this 0.5 you have to take here. So the next interval will be 0.5 and 1. ये remaining ऐसा ही रहेगा. तो अगर पॉजिटिव है तो ये इधर जाएगा, और अगर ये निगेटिव हुआ तो ये इधर जाएगा. That's it, simple. So here 0.5 and 1 is the next interval. Sign is positive and negative. Take the midpoint of these two, which is 0.75, evaluate the functional value, which is negative. So since this is negative, so you have to take the positive one. Take the positive one. So the next interval will be what? Take the positive one. So 0.5 and 0.75 will be the next interval. That means 0.5 and 0.75. Take the midpoint of these two. This is 0.625 and functional value is negative here. So you have to take the negative here. So you have to take the positive one. So that's why next interval will be 0.5 and 0.625, 0.5 and 0.625. Take the midpoint of these two, which is this. Find out the functional value at this point, which is negative. So this is negative, this is positive. So the next interval is 0.5 and 0.625. So this is the next interval. This is the midpoint, and slowly you will see that we are moving towards the root. So this interval is shrinking, regularly shrinking. So after 10 iteration, this is the, so we have to stop it here, and then the final root is basically this. So after 10 iteration you will see that this and this. So in the 11th iteration basically we have take the midpoint only. So this and this is the next interval in the, and take the midpoint is, which is this. So this is the solution. Okay, so I think you understand this method. Here we have already given third example also. So you will try to solve this problem. Here the interval is -3 and -2, because at f of -3 functional value is -14, negative value. At f of -2 the functional value is +1. So opposite to each other, so there will be a root. So try to solve this. We have already given the iteration, so kindly just verify the calculations through calculator so that you can easily apply this. Okay, so whenever classes will open, I will tell you how to use the calculator so that you can easily calculate rather than just doing hell calculation. Otherwise this will take lots of time. तो जैसी क्लास खुलेंगी मैं आपको बताऊंगा कि कैसे कैलकुलेटर्स की हेल्प से इसको बहुत जल्दी हम कैलकुलेट कर सकते हैं विदाउट एनी एक्स्ट्रा एफर्ट। ठीक, बहुत सिंपल कैलकुलेशन है, कैसे करते हैं वो मैं बताऊंगा। ओके ओके, थैंक यू।